Hi, I'm Sean Higgins, editor for SPAR3D.com and the SPAR3D newsletter. I'm here at ILMF 2017 with Michael Sitar, business manager for Airborne with Teledyne Optech. And as I understand, you guys are here showing off a new version of your Galaxy sensor. Is that right?
I am, Sean. So we've got a brand new sensor. It's the Galaxy T1000. This particular sensor is really focused on the wide area mapping segment. It has a variable power option, so we can get down as low as 150 meters for corridor power line type work as well. So it's a really broad sensor in terms of its application possibilities. One of the key features associated with the specific sensor is our ability to be able to move the field of view, the scanner field of view, dynamically based on the terrain response. And what that allows us to do is improve the collection efficiency. We can move the flight lines further apart, and at the same time it provides more consistent point density and point distribution.
So this would be, for instance, if you're flying it over a mountain range, instead of the mountain range getting sort of a wavy swath, it would make sure that it's totally
That's
straight.
correct. So the goal is to maintain a fixed width swath over the ground regardless of the terrain variation that occurs. And so that allows us then to have that predictable point distribution and then move the flight lines further apart when it comes to the mountain peaks.
So what's new about this particular Galaxy sensor that you're showing off at ILMF this year?
Okay, so that's a great question. So we introduced the Galaxy, the original model, about a year and a half ago. This brand new model has 1 million samples per second, so it has a very high point density capability. And then when you combine it with up to 8 returns, that's up to 8 million possible measurements per second. So it's quite powerful in that respect. Some of the other feature sets we've included, we've increased the scan product, and what that does is increase the efficiency of being able to move the scanner more quickly, wider fields of view, to be able to really distribute that high point, that higher emission rate. And one of the other things we're incorporating in this sensor is we've increased the amount of terrain variability that we can accommodate with the swath track feature.
So it sounds like the big changes or the developments over time have been adding these sort of configurability options to it, or these various types of technology that help people work in different sorts of environments where they couldn't have worked before.
You're absolutely right. So what these innovations that we incorporate are things and problems that come directly to us from our end users. What are their challenges in these different environments in their applications? How can we leverage some of the existing technology more effectively to overcome those challenges and provide them more productivity in the long run with high quality point data?
So how have people been taking to it so far at the conference? What sort of questions are you getting about it?
Well, we get a lot of feedback about the swath tracking capability. One of the other feature sets includes the ability to be able to solve for the blind zones associated with tracking more than one pulse in the air at a time. So the newer sensors, we emit a large number of pulses, but then we're also tracking more than one in the air at the same time. And so be able to manage that and be able to have consistent point density in very high terrain at high altitude with high sampling rates is very difficult to overcome, and we spend a large amount of time in algorithm development to be able to solve that problem for our end users and improve the overall productivity of the sensor.
Wonderful. Well, it sounds like a great product.
It is. Thank you.